All right, so we're going to now do this last problem where we derive Kepler's harmonic law from the gravitational law of Newton, assuming a circular orbit. So, to start, first, the gravity force on the moon from the Earth, G, mass of the Earth, mass of the moon, over r squared. Second thing is, the moon moves around the Earth in a circular orbit so that the speed is 2 pi r divided by t. Okay. And the last fact is that the acceleration of the moon around the Earth is given by v squared over r. These three facts are enough for us to come up with the t squared over r cubed law that we use in the previous page. So we have g, mass of the Earth, mass of the moon, over r squared makes the moon accelerate in a circle around the Earth. Interestingly, this means the moon mass cancels. One of the r's cancels on this side. And so we'll simplify. We'll get g, mass of the Earth, divided by the distance from the Earth to the moon, equals plain old v squared. Now I will substitute into here. So we get g, mass of the Earth, divided by r, equals 4 pi squared r squared all over t squared. Now let's do some simplification. We'll multiply both sides by r so that we end up getting g, mass of the Earth, equals 4 pi squared r cubed over t squared. Now let's flip a couple things here. We'll multiply both sides by t squared. We'll divide both sides by r cubed. So we end up getting t squared over r cubed times g, mass of the Earth, is 4 pi squared. Finally, we get t squared over r cubed for the moon is 4 pi squared over g times mass of the Earth. Now here's the thing. This is true for the moon, okay? It's also true for any satellite. So I can actually write t squared over r cubed for the moon is this, but also for a satellite, it's that 4 pi squared over GME. So what that tells me is that this dude is equal to that dude, and hence we come up with the original statement of Kepler's law of t1 squared over r1 cubed equals t2 squared over r2 cubed. Now, applying this to get the mass of the Earth, I'm going to actually back up to this formula right here. So I get t of the moon squared over r of the moon cubed equals 4 pi squared over g times mass of the Earth. When we isolate, so after doing some algebra, we're going to end up getting that the mass of the Earth equals 4 pi squared rm cubed over tm squared with this g down here. One small thing, this is good, and this is good, but the period of the moon is going to be 27 days times 24 hours times 3,600 seconds. So that when we isolate, we end up getting the mass of the Earth is equal to about 6.2 times 10 to the 24th kilograms when we solve with this, compared to like, I think 5.98 times 10 to the 24th in real life. So, yeah, it's okay. So that wraps up your practice test, and we will be pretty much done here, and I'm going to put this in Haiku right now.